Hello, welcome to the video in which we discuss some basic definitions in graph theory. The content described here is taken from the graph theory definitions page of Wikibooks. First we are going to discuss graphs, nodes and edges in graphs. A graph is an ordered pair usually written G equal to V comma E. Here V and E are two sets associated with the graph. The first set V is called the vertex set and the second set E is called the edge set. V is the vertex set V is the vertex set whose elements are called vertices, and they are also called nodes in the graph. Conveniently we can write V of G using the single letter V. E is the edge set whose elements are the edges or connections between the vertices of the graph, and this set is often denoted E of G, and just you can represent it just by using the single capital E. If the graph is undirected, then the individual edges are unordered pairs of vertices. For example, UV. There we do not consider the position of the vertices in this ordering. We do not consider the position of the vertices as different. UV will be treated equal to VU. The position of the vertices are not important. If the graph is but directed, then the edges are ordered pairs. But in the case of a directed graph, the position of a vertex is very important. Here U is present in the first position and V in the second position, so we cannot treat that equal to VU. UV cannot be equal to VU, and they are treated as different. When can we say that two graphs G and H are equal? For two graphs G and H to become equal, they have to satisfy the condition that their vertex sets are same and the edge sets are same. That is, V of G equal to V of H and E of G equal to E of H, and that is the condition required for two graphs to be equal. Now we define order and size of a graph. Order of a graph is the number of vertices present in the graph. So if we consider this graph as an example, here 3 vertices are present, so 3 is the order of the graph, and we denote that order by small n. The size of the graph, on the other hand, is the number of edges present in it, and so size is equal to cardinality of E. You can write it equal to cardinality of E. The special situations of these values are very interesting. If n equal to 0, if n equal to 0 and m equal to 0, we have that graph, and that graph will be called empty or null graph. When n equal to 0 and m equal to 0, the graph obtained is called empty graph or null graph. But when n equal to 1 and m equal to 0, then we get a graph called trivial. We get a graph, then the graph, such a graph is called a trivial graph. But if n is greater than or equal to 1 and m equal to 0, then the graph is called a discrete graph. Undirected graphs, as we have mentioned above, an undirected graph is a graph in which edges do not have directions. An example of a directed graph, on the other hand, in a directed graph, edges get direction either in one direction or two direction. And the example of a directed graph is shown here. You can see the directions associated with the edges in this graph. In a detailed definition of a directed graph is given here. A directed graph or a digraph. Shortly you can write a digraph. Directed graph or a digraph is an ordered pair D equal to VA. D stands for the directed graph D equal to V comma A, with V is the set of V is the set whose elements are called the vertices and nodes. But that is exactly as in the case of undirected graph. But A, you can see here, instead of E we use the letter A. Is the set of ordered pairs of vertices. They are also called that is the ordered pair of vertices are called the arcs in a graph, in a directed graph. They are also called the directed edges or arrows. Three different names are used to represent that directed edges. That's arcs, directed edges, or arrows. An arc A equal to xy is considered to be directed from the vertex x to y. Once again, an arc A equal to xy. An arc A equal to xy is considered to be directed from x to y. And y is called the head and x is called the tail of the arc. Here, y is called the head. Y is called the head and x is called the tail of the arc. Y is said to be directed to y is said to be a direct successor of x. Here we say that y is a direct successor of x and x is said to be a direct predecessor of y. If a path leads from x to y, then y is said to be a successor of x and reachable from x. We say that then let's consider a path from x to y. Then y is called a successor of x and reachable from, and we say that it is reachable from x, and x is said to be the predecessor of y. The arc xy is called the arc yx is called inverted. It's called an inverted arc of xy. Here in this case we treat the arc yx and xy as two different arcs. Okay, now you can see an example of a graph here. It is given here. In the image you can see a graph. The set of the vertices of the graph is v of g. Set of v of g is equal to 1, 2, 1, 2, 3, 4, 5 and 6. There are 6 vertices. 1, 2, 3, 4, 5 and 6. But the edge set of this graph is given here. E of g is equal to 1, 2, 1, 5, 2, 3. See that in look at the figure and you can see that it is 1, 2, 1, 2 and then 1, 5. From 1 to 5 there is connection, and from 2 to 5 or in between 2 and 5 there is connection. 3, 4 connects 3 and 4, and 2 3 connects 3 and 2, and x 6 6 4 6 4 connects 4 and 6. Okay, with this example we stop this video. Thank you.